Hi, in this video I'm going to introduce you to exception handling. Exception handling deals with problems that occur during runtime. It provides information about the existing problem. It allows you to take appropriate action. Exception handling makes your code more fault tolerant and more robust. Let's have a look at the Java exception hierarchy. Here is an excerpt. At the root, we have class throwable. From throwable derive errors and exceptions. There are many types of exceptions: runtime exceptions, I/O exceptions, SQL exceptions, and many other types of exceptions as well. For now, I want to focus on arithmetic exceptions. Let's look at an example. This is from figure 11.1 from the detail book How to Program, and you can see we started out by declaring a method called quotient. Quotient has two parameters: an numerator of type integer and a denominator of type integer. The method returns an integer quotient, and it is calculated by dividing the numerator by the denominator. At this point, we're going to fill in the main method. So here I'm going to create a scanner. My scanner is based on data from the standard input stream, the keyboard. I just call it input. I'm going to prompt the user, say please enter an integer numerator, and then I use the method nextInt to read in the numerator. I'm going to prompt the user again. I say please enter the integer denominator, and once again we're using nextInt and assigning the value to denominator. At this point, we're calculating the result. We're calculating the result by calling the method quotient, and we're passing into quotient first the numerator and then the denominator. We're printing the result where I show that the numerator divided by the denominator is the given result. We are scrolling a little bit over here. You can see the result. As a matter of fact, let's make the whole line visible here. So at this point I'm going to run the code, and we are just entering some numbers. Let's say I say 100 divided by 7, that would be 14. 14 because this is integer division, so integer division truncates. If I would run it again, I could say something else. I could say, for example, hello divided, oops, there is an exception. It's an exception, let's scroll up here, called input mismatch exception. It's an input mismatch exception because we were expecting an integer, but I provided a string. Let's run it one more time. This time I'm going to divide by 0. So here, as my denominator, I'm going to enter 0. And once again, I have an exception. This time, this is called an arithmetic exception because this is a problem with the integer arithmetic. I'm not allowed to divide by 0. So far, we encountered two types of exceptions: the arithmetic exception and the input mismatch exception. Notice, Java allows division by 0 for floating point numbers. 7.5 divided by 0 results in infinity, but Java does not allow division by 0 for whole numbers. 5 divided by 0 throws an arithmetic exception. Let's have a look at the output that we received as an exception was thrown. Here we have something that is called a stack trace. It starts with the name of the exception and is followed by the method callStack. So here at the different add statements you can see the different methods that were called at different positions. The first add statement here is the throw point. The exception was thrown in method quotient line 10. In the case when we entered hello, the exception was thrown in the method throw4 from type scanner. It says unknown source. That indicates that the debugging symbols of the method's call are not available to the Java virtual machine. All those classes here, scanner, 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 are from the Java API. I go down until I reach the first statement in my own code. Here it says divide by 0, no exception handling. That's the code I'm interested in. That's where I'm looking for the potential cause of the problem. It shows me the name of the class and the line number. Also gives me the method it happened in main. The stack trace includes a lot of useful information that can be very helpful when debugging. So I want to encourage you to look at it and take advantage of the information provided. Let's have a look at a stack trace here in Eclipse. I'm running my program again. I'm entering 100 divided by, let's say, 0. And it shows me here that we have an arithmetic exception. My first add statement points me to method quotient in line 11, right here. So line 11 in method quotient is the very statement that causes the problem. Right here I do divide by 0. But if I would have looked at one statement below, at the second add statement, it would have told me this is in main line 23, right here. And 23 in my main method is the very statement that calls the method quotient which causes the exception. Let's have a second example. I'm going to clear my output and I'm going to run again here. This time I say 100 divided by hello. We get an input mismatch exception. First add statement points me to scanner, throw4, scanner, scanner, scanner. So at this point I reach the first statement in my own code. This is in main, this is in line number 21. Line number 21 is where I call the next int method from input, but the user provided a string. So here we have the input mismatch exception because the token read by my scanner was expected to be an integer, however in reality it was a string.